This video is about the determination of pH from EMF measurements. You know, pH is the negative logarithm of H plus ion concentration. Here we are going to find out pH value from EMF, measured EMF value. That means we have to construct a cell in which one of the electrode which is reversible to H plus ion concentration, which is reversible to H plus ions. So that means, just imagine we are going to find out the pH of a particular solution. The instrument is set up to calculate the pH of this particular solution by using EMF is we have to take this solution, the solution of unknown pH, as the electrolyte. Then we are going to construct a half cell by dipping an electrode into it, and we have to pair this half cell with a reference electrode. Okay. From the EMF value, we can find out the pH value because this electrode is reversible. This half cell is reversible to H plus ion concentration. For example, we can determine the pH of an unknown solution by using Kinhydron electrode and by using glass electrode, etc. Okay, let's go to the details of pH determination. So here, in the pH calculation method, we can use our Kinhydron electrode as a cathodic cell as well as an anodic cell. So here, first of all, I'm going to consider that the Kinhydron electrode, saturated Kinhydron electrode, and the solution having unknown pH is as a part of anodic half cell. Okay. That is, the cell can be represented like this: platinum, solution of unknown pH, saturated with the Kinhydron electrode, saturated with Kinhydron electrode, and it is paired with a reference electrode. Here I am using standard Calomel electrode. Okay, here. Now, what about the cell reaction of the anodic half cell? Here, the hydroquinone is converted into Kinhydron, 2 H plus ions and 2 electrons. And the EMF of this cell, I'm going to take it as EL since it is the left half of our cell. So EL is equal to E0L minus RT by NF. Here N is 2, so I'm going to take it as 2F. Ln QH2 divided by Q. The H plus term is also there, but I'm going to split it. So it will become like this, plus RT by here 2F Ln H plus raised to 2. Right? But this 2 term will be the ln x raised to n equal to n ln x. So this will come here into 2, and this 2 and 2 will be cancelled, and we will get RT by F ln H plus. Okay. So in all these terms, activity is there. Activity of QH2 divided by activity of Q, activity of H plus. Okay, just assume that the activity of effective concentration of hydroquinone divided by quinone is unity. So this term ln1 equal to 0. So this term will be cancelled, and we will get EL equal to EL0 plus RT by F ln A H plus. Right. Then if I convert it into the logarithm base to 10, will be EL equal to E0L plus 0.0591 log AH plus. If I take it as EL equal to E0L minus of minus 0.0591 log AH plus, then this minus log AH plus, that is negative logarithm of concentration of H plus, is the pH value. So this is EL equal to E0L minus 0.0591 pH. Okay, this is the electrode potential of the LHS side, or it is the electrode potential of the half cell containing solution having unknown pH. The cell EMF, we have to calculate the entire EMF of this cell. So we got EL equal to E0L minus 0.0591 pH. Right. Actually, the E0L value is 0.099. So we can take it as 0.099 minus 0.0591 pH. Okay. Now let's calculate the EMF of the cell. So EMF equal to E right minus E left here. So E standard right minus right means standard Calomel electrode minus EL value. Then we know EMF of standard Calomel electrode is 0.2415 minus our value, that is 0.699 minus into minus plus 0.0591 pH. Okay. Just rearrange this equation. So we will get 0.0591 pH equal to E plus 0.6. Okay, we can minus these two values. So we will get 0.4575 minus 0.4575. If we bring it LHS side, we will get plus 0.4575 divided by, okay, we can bring this term here. So we will get pH equal to E plus 0.4575 divided by 0.0591. So this is the pH of this electrolyte when this is a part of anodic half cell. Now if it is a part of cathodic half cell and the reference electrode is standard Calomel electrode, then the cell can be represented like this: standard Calomel electrode, solution of unknown pH, saturated with Calomel, saturated with the quinhydron, and platinum. Okay, here E value equal to ER minus EL. ER is for our quinhydron electrode containing solution of unknown pH as the electrolyte. So the value was 0.699 minus 0.0591 pH and minus 0.2415. This is about 0.4575, E equal to 0.4575 minus 0.0591 pH. So if we rearrange this equation, we will get 0.0591 pH equal to 0.4575 minus E, and pH value equal to 0.4575 minus E divided by 0.0591. So this is the pH of the solution when it is a part of cathodic half cell. Okay, from these two equations we can calculate the pH of the unknown solution. This is how we calculate pH value by using quinhydron electrode. Then let's go to glass electrode. Next one, by using glass electrode. I have to mention one more thing, that is, if we use quinhydron electrode to find out the pH of a particular solution, if the pH is greater than 8, then we cannot find, or we cannot accurately find out the pH of the particular solution. So quinhydron electrode is not applicable to the electrolytes having pH value greater than 8. Okay, next one, glass electrode. Okay. Glass electrode is the common electrode which is used to find out the pH of electrolytes or pH of solutions. So it is a common method, and it is a simple method. It is used for the solutions containing oxidizing or reducing compounds. It can also used for organic compounds also. Organic compounds. We can also use it for organic compounds to find out the pH of organic compounds. And it is also used for the solutions containing oxidizing and reducing compounds. Okay. And the most interesting feature of glass electrode, which is used as a pH detector, is it is not easily poisoned. So it is not easily poisoned. So hence we can use it for a long time. Okay. Glass electrode, it is a simple apparatus. Okay, glass electrode is a glass tube containing a glass bulb at the tip, this containing H plus ions. Most commonly we are filled it with, this glass tube is filled with a 0.1 molar HCl solution, and this glass tube, and to this HCl solution we are dipping a platinum electrode. So this is a platinum electrode, or we can use silver rod coated with a silver chloride, AgCl. We can either use platinum electrode, or we can use silver coated with the silver chloride. So this is the glass electrode, and this is dipped into the solution of a solution having unknown pH. So this is the solution having unknown pH. Now if you want to find out the pH of this particular solution, we have to measure the EMF of the cell. So we have to pair this half cell with another reference electrode. From the EMF value, we can find out the pH. Okay. And one more thing we have to know, that is this glass tube and the glass bulb are made up of special glass material. That is, this glass material is a conducting material, a special type of glass material, conducting material, and the melting point of the substance is also very low. Okay, then moving on to the pH calculation. If EMF of glass electrode is Eg, then Eg equal to E0G minus E0G plus RT by F ln H plus. The glass bulb containing 0.1 molar HCl, so the potential difference of this particular electrode depends the concentration of H plus ions. That is why EMF E glass electrode equal to E0 glass electrode plus RT by F ln H plus. Okay. Now we can convert it like this: Eg equal to E0G plus 0.0591 log. That is, we are going to multiply this with 2.303 and converting this into log to the base 10. So log H plus, and this is equal to Eg equal to E0G minus of minus 0.0591 log H plus. This is the negative log H is the pH. So Eg equal to E0G minus 0.0591 pH. Okay. This is the EMF of the glass electrode which is dipped into the solution having unknown pH. Now we are going to pair it with the reference electrode. So the E cell equal to E reference electrode minus E glass electrode. Okay, let's consider that the reference electrode here we are going to take a standard calomel electrode. That is, E cell equal to E standard calomel electrode minus E glass electrode. So E cell equal to E standard calomel electrode is 0.2415 and Eg is E0G plus 0.0591 pH. From this, 0.0591 pH equal to E cell minus 0.2415 plus E0G, and pH equal to E cell minus 0.2415 plus E0G divided by 0.0591. So this is the equation which is used to find out pH of solution by using glass electrode. Okay. One of the important demerit of glass electrode is this glass electrode E0 value, E0G value of the glass electrode depends the material of the glass material which we are used to make the glass electrode. So it may be varies with the E0G value is not constant, so we cannot substitute the value of E0G in this equation. It varies with different materials, different glass materials. So this value is different for this E0G value is different for different glass materials. So that is the only one demerit of this method. All other things are fine. So this is how we find out pH of an unknown solution by using electrodes. So this is all about the pH determination of unknown solution by using EMF value.